I'm Mike Cafferty. I lead the sales function for WeShape. So who are we? We've put this session on together today, and WeShape are a technical consultancy. So hopefully you can see that in front of you. The top left just gives an idea of who we are. We're a hybrid consulting model, which means that if we work with some customers to build roadmaps and own end-to-end projects, whereas with others, if they're just missing a little bit of expertise, we use our expertise to augment some teams. Across the right-hand side is our capability. So this is kind of where we specialize and what we're best at across data, DevOps, cloud, and software solutions. And we can deliver that in the UK, as well as solutions from our nearshore capability across Eastern Europe as well. We also have quite an exciting arm to us that's growing at the moment, which is our growing Tech Academy, which predominantly is GCP specialized consultants at a junior level that we bring into the business, train up, and then deploy onto projects. What makes us reasonably unique is that bottom left box, which is the events piece. You're at one now. So we run webinars like this on a monthly and quarterly basis. We also work very closely with London tech leaders. So that is a quarterly meetup of technical leaders in London that get together to talk about all sorts of things from industry trends, some content, and just get together to socialize and build a bit of a community. Also, we have London DevOps, which is a monthly get-together of our DevOps practitioners, which is where we find a lot of our expertise and where we keep up with industry trends, as well as one that's not on there, which is Data Engineers London as well. So exactly the same, data professionals getting together to discuss industry trends, learn off each other on a monthly basis. Last but not least, on the right-hand side at the bottom there, we've got our awards and our partnerships. GCP is a big one for us. We're looking to grow massively in terms of our partnership with GCP. We work really closely with them to go to the market to help our customers implement and migrate to GCP. But we also work with AWS as well. But don't take our word for it. We are also award-winning. Over the years from 2022 and 2023, we've won awards in DevOps and at the IT Service Industry Awards, as well as being a B Corp, because we do like to give back to our local community as well. If anyone's got any questions about any of that, you can contact me. I'm sure Alex will share some details, but without much more of an ado, I will pass back to Luke and the team to get us started on today's session all around GCP.
Thanks for that, Mike. So yeah, that's all from us. Let's get into the webinar. So I'm going to go off stage and then I'm going to bring on Attila and Luke to tell you all about GCP. Thank you.
Great, we're on. Can you hear me okay? Yeah. Okay, great. So we are here today to talk about GCP, cloud adoption, big data, ML, and AI. So let's start off the conversation with a quick rundown on what the cloud market looks like. So from a lot of the analysis out there, IDC and Gartner are quite aligned in their belief that over the next year, we're going to see approximately 22-23% growth on world public cloud consumption. And in Europe, the market is always slightly different between Europe and America, but in Europe at the moment, 95% of companies are using the cloud, and more than a third of them are going to have at least half their workloads in the cloud in the next year as well. So this is all driven adoption because of a couple of different reasons, I suppose. One of them being, if you look at the old Gartner hype cycle, right at the tippy top there is the generative AI sort of movement, which is obviously driving huge amounts of activity in the market. Separate to that, I think last year there was quite a drive towards this concept of the multi-cloud or also hybrid cloud movement, where a lot of analysts are still predicting that multi-cloud and hybrid cloud will push more and more cloud adoption, whether that's because they are merging on-premise workloads with off-premise ones, or that they are going through resilience and driven by European DORA regulation. Some of the requirements to have resilient cloud providers, or at least that's one of the strategies being implemented to achieve DORA compliance. So that kind of sets the stage of the market. So let's just introduce ourselves before we go any further. My name's Luke Ashbrown. I'm the Director of Technology Consulting here in WeShape. I have, like Alex was saying, many years of experience across software engineering, platform engineering, and in WeShape, I deliver a lot of technical requirements and client-facing understanding of our work with them, as well as shaping the teams and overseeing delivery, providing delivery assurance on our projects across cloud, data engineering, and software development. Great. So Attila, over to you.
Sure. Hi, I'm Attila. I'm a senior data and AI consultant with over 15 years of experience across the table. I worked on the client side for car manufacturing, entertainment, and marketing automation industries. And on the agency side, I work for a Google Cloud consultancy. Currently, I'm working for the English Cricket Board. So I'm specialized in cloud architecture with over 6 years of experience and 13 certificates across the 3 main cloud providers. My primary background is data, but I'm involved with AI for about 3 years now. So my main focus as an architect/consultant is to understand the business needs and motivations and translate that into technical project plans. And now it's back to Luke, who is going to talk to you about the cloud landscape.
Thanks, Attila. All right, so yeah, the cloud landscape. Get back to the basics. What is it really? What does it look like? And the old meme is always good. It's just other people's computers, isn't it? So who are providing all these computers? There's quite a field, and this is only a tiny segment of providers. Some of the higher tier or larger adoption players in the market. But when we talk about this field, usually the 3 leaders are the drivers in the conversation. So yeah, you've got AWS, Azure, and Google Cloud, of course. AWS having the biggest market share, Azure following them up, and then Google Cloud. I'll come back to the strengths and weaknesses a bit later. But in terms of why the adoption is happening, and it's a bit of a driver and discussion around this whole multi-cloud, hybrid cloud, and various other kind of as a service adoption that's going on. This is a common graph I'm sure people have seen before. The idea that on-premise you have total vertical responsibility for everything you run, and the driver to go to cloud providers, which are infrastructure as code, or not code, infrastructure as service providers, are allowing you to offload some of the liability and responsibility and cost of operating those lower level components of your infrastructure. And as you go up into platform as a service and software as a service, you're thinning the layer of responsibility you have to take care of. And you might pay a bit of a premium for those things, but it's all about offloading the cost and the liability while gaining sort of a risk nullification or a risk reduction, and just a complexity, operational complexity reduction as well, which often leads to agility and other advantages in the business. So I'll hand back to Attila now to talk about the different scenarios in which these different arrangements of cloud and multi-cloud and hybrid cloud can be used.
Sure. So let's start with the obvious one, which is a single cloud or a standalone cloud solution. It's fairly self-explanatory. You're using a single cloud provider. This could happen because you don't want the hassle of managing hardware or on-premise environment, or you made a strategic decision for a specific provider, or maybe you're just testing out a proof of concept and you go for one of these providers. What I want to talk a little bit more in details are the more challenging aspects, like, for example, the multi-cloud approach. So there are scenarios when you might want to consider more than one provider. There are no theoretical limits how many of them you can use, and these can be public or private clouds or a combination. It's really based on your strategic needs. So the scenarios being, you're already using, for example, a public cloud provider, but you want to use a specific function from another one, or you want to avoid the reliance too much on a single vendor, or you have a private cloud already, but you don't want to invest the resource developing some of the non-business critical functions or services that are already readily available in other public cloud solutions. So what are the main advantages? You can pick and choose the best of services from each provider. It could reduce your cost if you're mixing the services effectively. You could use it as a leverage to drive price negotiation with the vendors. You could reduce your risk by not relying too heavily on a single cloud provider. Or you can always keep an eye on the latest innovation and taking advantages of the emerging technologies. Now, as such, it comes with disadvantages as well. Multi-cloud approach can be complex due to the fact that you're dealing with more than one provider and solutions. You clearly have to calculate the gains and losses to ensure the overall approach is profitable. And you need a team that has knowledge of multiple cloud provider, which increase your cost and training time. However, if you're not a cloud-only organization, there are other options as well. So, for example, using your on-premise solution and enhance it with a cloud provider. Again, this can be a public or a private cloud. It's your choice. So the most common reasons are increasing your performance and reliability, taking advantage of managed services and automation capabilities to reduce your operational overhead, cost savings through reduced operational cost, and potentially maybe even you can reduce your team sizes. And maybe as part of your business transformation, you can make a gradual shift towards the cloud. So advantages. You can enhance your capabilities quickly and easily, taking advantage of what's already available, and you don't have to worry about how can you develop these in-house. Quite often these cloud solutions are either reasonably priced or operating as a pay-as-you-go model, which could really help drive down the cost. Cloud providers usually promise a minimum of 99.99% SLA, which is much harder to achieve on-premise. And a lot of organizations are unsure if they should commit to the cloud and how would they be able to do that. So this approach would help them gradually make the shift, allows them to try it one function at a time. Now, no denying there are disadvantages, and mainly this shift would require most of all a mindset change. For example, operationally, you have to adopt the mentality: if you don't use it, turn it off or create and destroy. Also, from the cost point of view, instead of the upfront and well-known capex cost, now you have to deal with an ongoing OpEx cost. Just a little bit more about the cost management. You really have to establish an efficient cost monitoring and how to step in if necessary. We all heard about horror stories about someone forgot to turn off something and it produced a huge amount of cost. With an effective monitoring and budgeting alerts, you can quickly overcome this. You also have to set up and maintain an infrastructure between your on-premise network and the cloud. That alone introduces complexity, but further that, you have to ensure both on-premise and cloud resources are working together efficiently. So there is another tier to this, a hybrid multi-cloud system. So you can combine the multi and the hybrid cloud approach. So your on-premise environment with multiple cloud providers. I don't really want to go into too much into details. It's not common, but essentially combines the two strategies I was talking about. And yeah, with that, I would hand it back to Luke, who can talk more about the public cloud space.
Okie dokie, yeah. So public cloud, we'll start off with bringing back this slide. Basically, how do you make the choice? Who are you going to use? From a provider point of view, I think actually my first points there, founded, launched might have been a better word for this. Amazon launched AWS in 2006, and Azure was launched in 2010. Now, a lot of people will say Google Cloud was launched in 2011, but I guess a prior form of it launched in 2008 in the form of App Engine, which they ran for 3 years in a full release version, but were trying to find their market fit. But it still launched and it still existed, and they were basing their infrastructure development off the experience there. Now, in terms of the attributes or qualities of each of these, I think it's an interesting set of things to consider when you're trying to choose your providers. In AWS's cases, now it's my opinion, I think there are quite a lot of reports and analysis on cost that will prove it's true, but Amazon is generally a little bit more expensive total cost of ownership compared to the other providers. But they're driven from the strength of having enormous diversity in the resource types they have, over 200, I think, at the moment, different types of service or resource types that can be provisioned into their infrastructure, into their environment. The adoption leads to enormous skills availability. There's not an engineer I know who hasn't done something on AWS. Everyone's used it. And the availability of good quality skill sets is pretty prevalent there. And AWS has the biggest scale, being the longest in the tooth, the most data center locations, and just sheer count of data centers. They are ahead of everyone else in that. Azure's qualities really come from their understanding that people wanted powerful application capability without putting too much managed service on top. So they started with VMs, and they're really the prime place if you need that enterprise support, Microsoft application layer support. They do tend to be quite reasonably priced, actually, I've found. And they're really good, again, with that enterprise focus. But if you've got a regulation or a compliance kind of case you need to worry about, they're a good bet. And then in Google's case, like I said, founded after AWS, but technically before Azure. I feel they're definitely more cost effective than the others by a margin, which I'll go into a bit later on. The user experience, I think Google Cloud has been driven with this concept of simplicity as a core quality and a core deliverable in their design. And that comes through in its use cases, its service and resource design ethos, and also just in the experience. When you use the console, you can see it. It's just so simple to use. I think it shines really strongly in the large data and analytics space, as well as being a pretty powerful option in the AI space. And again, back at the beginning, one of its core ethoses and design principles was that they were going to focus on their network stack. And they really do have a network that performs at an exceptional level in terms of throughput, latency, resilience, and in terms of feature set, it really is impressive with its capability of delivering global networking, allowing all your different environments across different regional areas to be totally merged, which is impressive. And with its edge connections, the network again lending some real quality to Google's offering. They have more edge locations than anyone else, which is surprising given AWS's heritage. But they have a wider distribution, or a higher count of edge locations, which is really good for interconnecting, especially in this multi-cloud, hybrid cloud world. Your on-premise or your other cloud providers back to Google, they really are going to have good options available in terms of location and speed available to make those connections. Right, so I have just talked about Google, and we are kind of here today to focus on Google's offering and what strengths they can bring to the market. So I'm going to start off with some of the advantages I think I've seen in my use cases of it, and then some broader, generally accepted advantages Google Cloud shows and strengths it shows. So from the point of view of compute, I'm a big fan of the compute side of Google. Kubernetes came from Google. Their Borg platform was how they ran their containers in-house for oh gosh, I mean, it must be 20 years now, maybe 16 years. I think it was 16. I'll have to double check the dates on that. But Kubernetes now recently celebrated its 10th birthday, and the Google Cloud offering, GKE, it really is. I think it's the top tier implementation of Kubernetes in the market. They have low-level network integration, native pod networking, and identity and access control integration with the cloud environment. And it's just very, very well done, as well as the lifecycle and management experience of your underlying compute resource, the worker nodes and the master control plane. The upgrade lifecycle on those, it has been something that's been really solid and resilient for me in all my use cases. So a robust and smooth experience is what I'd call it. The second advantage, what comes out of some experiences that I've had in its simplicity, and it's not just the user experience or the user, the graphical user interface experience. I'm talking about the services, their simplicity of operation. Oh, thank you. I forgot to move the slide. So in terms of the simplicity of its operation, I've used AWS's ECS in the past, and what I found quite a stark contrast was the amount of prerequisites you have to set up in AWS to get ECS running. You have to set up your VPC, your subnets, security groups, compute resources, all sorts of just bits and pieces that need to get put in place before you can spin up the ECS workloads. In Google Cloud, I have my project. I don't need to create a subnet or a private network or anything. I just create Cloud Run, which runs my containers, and it takes care of all the resource provisioning behind the scenes. One of the surprising things, it even provides auto scaling. And by default, I think it's 100 requests per minute. I'm going to say 100 requests a minute. It'll run on one instance, and then it'll just linearly scale every 100 requests a minute to 2, 3, 4 instances, and it will scale back down all the way to 0, which you don't get with most other providers either. So you're only paying for basically what you're running, unless you put the guaranteed running configuration, and you can configure all of that. All of it is very flexible, but ultimately the default is so easy to use. It's just the focus on the core value of simplicity really shines through. I think some of the more broadly accepted values in Google Cloud come across the other areas, and I've mentioned some of them already. In terms of the networking experience, again, I've mentioned the edge location value that it offers, and just its performance, latency, throughput. It's an incredibly powerful network, and again, simple to use too, with some advanced, interesting features like cross-project networking, XPN, global networking, and things like that. So it got an awful lot of flexibility, while not overcomplicating it either. In terms of costs, most of the material I've looked into and some of my own cost estimations and other projects I've worked on tend to agree with this number. Now, I'm going to disclaimer, it's not an official stance of any company. It's just down to the research I've done. I found this anecdotally to be proven true. Most people experience somewhere in the region of a 20% cost saving against competitors. And this is down to some of the cost saving measures that Attila will go into later. And then in terms of its capabilities, it's always held up as a provider that will shine in very large scale data analytics and AI ML world. So with that mentioned, I'll hand it back to Attila for exactly those topics.
Thank you, Luke. So yeah, big data. So what is big data exactly? So the definition, and I hate to say that, but big data refers to an extremely large and diverse collection of structured, unstructured, and semi-structured data that continues to grow exponentially over time. Essentially, that means that all the data available within your organization and potentially that you can collect from external sources. But how can you actually use that? First of all, you have to collect it, process it, and then you must be able to ask your questions. So the most common ways to handle big data is either data lake and a data warehouse or data mesh. So data lake and data warehouse refers to when you collect all your information and process it in a centralized location, or data mesh when each business unit has its ownership over their own data, but through strong governance, these data sources can be joined together. So who are the main players? There are many tools out there, including each of the big providers provide their own solution. So to choose between them, you need to evaluate based on your requirements and strategic posture. However, specifically, I'm here to talk about BigQuery, which is Google's flagship product for data warehousing and analytics. So why BigQuery? BigQuery is a great tool. I'm a big fan of it. I'm working with it for over 6 years now, and it offers a wide range of features, but most of all, it's petabyte scale cloud data warehouse, scalable and serverless, meaning you don't have to worry about the underlying infrastructure. Cost effective. You only pay for storage, which is about $2 per gigabyte, and query usage, which is about $7 and $8 per terabyte. There is a free and an on-demand tier. There are 3 different editions to choose from, so everyone can find the right pricing model. Designed for fast query performance and cost efficiency. However, to get the most out of it, it's recommended to follow the best practices. Security-wise, it offers column and row level security, be it identity and access management, Google or user-managed encryption keys, and integration with sensitive data protection to mask or anonymize data. There are inbuilt machine learning capabilities, which means you can use SQL language and the same user interface to create machine learning models. And also, I just wanted to mention that it natively integrates with Amazon S3, Azure Storage, Cloud SQL, amongst many other sources. So it's a great tool. But the main question is that why do you need big data at all? So big data has a lot of advantages. Allows you to understand your organization to the fullest, enhance and speed up your decision making, simplify operational processes, allows you to expand your business capabilities, and centralizing your governance and security. But the biggest advantage that everyone is talking about, that it enables you to start implementing AI. So where are we with AI? There is no question that the AI revolution really took off at the end of 2020 with ChatGPT. That really proved the point to everyone that complex problems can be solved with AI, and it can be used in everyday life. Since then, the market was flooded with different AI tools that frankly transformed the industry. So image generators are a good example. I worked with a dog food company who replaced the expensive and difficult live dog photo shoots with AI-generated images. Imagine how much easier to create these photos and how much time and cost it saved them. Also, if you watch the latest Google AI event, you really notice that Google is really focusing on AI innovation. Over 1.5 million developers are already using Gemini to debug codes, to getting insights, to building the next generation apps. Gemini itself is integrated with search, photos, workspace, mobile phone, and it's context aware as well. Project Astra is focusing on the video stream. So it's a video assistant that allows you to search with your camera feed, with your live video feed. Okay, so we all know AI is great, but how can you actually use it within your organization? There are the traditional entry points, AI APIs that offered out of the box by Google. For example, natural language, speech to text, text to speech, translation, vision, video intelligence. These are already available for use. For example, if you want to create a live translation app, you can just use the Google Translate API. Document AI. That can be a great help to process your documents and make their content available for search for you. Conversational AI can help you to create a fully comprehensive chatbot that can be easily tailored to your business. Gemini for Workspace helps your employees with AI coding assistant, document content, creative generator, not to mention text summary and generation. Vertex AI. This is where you want to create your own O2ML solution or your very own completely customized ML model. So what AI is capable today is to help to provide solution for some of your specific problem, enhance your business capabilities, or increase productivity. A few examples for these, like minimizing repetitive work, creating departmental specific documents, content materials, allows you to process and activate your documents and data, automate workload, or you can focus on any specific business problems you have. But to achieve that, you need your specific business data and serve that to the AI algorithm. So just a few examples. You want to speed up the content creation with your marketing department, use your existing branding and template as a source and use AI generator to create more content to speed up productivity. And now with that, I would hand it back to Luke, who's going to talk about the the financial element of it.
Yeah, I'm just going to stop the slideshow and reshare another version of it from my local screen. So one moment. Turn screen. There it is. Okay, I think we've got it. Yep, that looked good. Excellent. Yeah. Okay, so to carry on, in terms of the sort of different financial levers you can use to get started with your cloud journey in Google. With all accounts, you get a default free credit amount 300. I don't think that's particularly unusual, although I think it's a bit higher than most of the rest are offering. I know AWS do some as well. I don't know about Azure. I have to check. But yeah, it's a pretty generous amount which you can use for up to 3 months after you start off your account. And that's a really simple way to get going. On top of that, one of the things we actually participate in is the Google Cloud Partner process. So that allows you to work on pilot programs or proof of concepts, experimentation to figure out what kind of resources you can use and how you can leverage Google Cloud to achieve some of your business goals, as well as more productionizing kind of workloads and things that are focusing on ready to market deployments of your applications into Google Cloud. So they'll do part funding where a portion of your projected consumption of resources in Google Cloud can be refunded or paid up towards your consulting costs or even just back as credit against your account in terms of resource consumption. And by part, I mean, they'll figure out how much you're projecting you're going to consume, and after a little bit of consumption, they'll be able to then refund you. I believe that's how it works. On top of that, they also have the sort of startup funding area. So this is programs which allow you to leverage more funding from the point of view of you're really a startup company and are trying to build up your core product from the beginning. Good for those early stage businesses. So there's a UK startup program, and there's ones in different countries as well. In fact, if you go to startup.google.com, they have a whole bunch of initiatives for different types of startup scenario situations, women in tech or different minorities, and there's a whole catalog of initiatives that they're running in that space. Great. So and Attila, you want to talk about the next bit?
Yeah. So I wanted to share a few stories around cost savings. So committed use discounts. I work with a Google consultancy, and one of my clients migrated their workload to Google Cloud. Obviously, the initial focus was on the successful migration and operation. However, later on, they signaled they would be very keen to reduce their costs. We done a cost analysis for them, which showed that they had a consistent and significant compute engine usage. They were in a multi-year commitment deal with Google, so it was sensible to recommend a committed use discount, CUDs, which they could get 28% discount over 1 year or 46% over 3 years commitment. So they decided for the 1 year commitment option, which instantly reduced their cost over a quarter for compute engine usage. 3 tiers. Actually, I worked with Luke on a proposal for a UK-based RegTech company. So the current Postgres database is unable to handle a specific customer product calculation at scale. They were thinking of leveraging BigQuery analytics capabilities. Currently, the database in question is about 10 gigabytes, but they only want to use 2 tables for these calculations. So they were quite worried about the runaway costs. So I showed them that each month, 10 gigabytes of active data storage is free. So essentially, they could host their entire database. And 1 terabyte of querying, which is essentially 100 times of the entire database, is also free. Even after this, the query cost is around $7 to $8 per terabyte, and storage cost is about 2 cents per gigabyte. So that confirmed for them that they can handle this cost element. And for price drops, sometimes Google announces price drops. A really good example for that, last December, they announced a 75% reduction on vector embedding creation, which was very unexpected, but very appreciated. I worked with a client where we developed an AI solution to fix their broken product attributes. It cost about $150 a day to run, but after this announcement, it's just dropped under $40 per day. So the whole project suddenly became more valuable. So these are just some of my experience that I came across with Google, but I would hand it back to Luke now.
Thank you. All right. So with that, I think we'll have a little run through some a story or two. I think it's one story at the moment. Yeah. So the user journey of using cloud, Google Cloud. I think there are some starting point things I wanted to mention first. When you start down this road, some technical advice is when you create your account, you got to enable some APIs, you got to generate some sort of foundation level stuff. But I think step one is you've got to get your landing zone concept figured out. Like I said earlier, you can create a project and just load containers in, and it's amazing how simple it is to do that without any effort. But it's also a bit of a risk in terms of, or a temptation just to do the quick thing. Focus on a landing zone approach, a strategy, a framework on how you're going to use it. One of the areas to think about is your identity and access control, security management, guardrails, sort of like account limits, and also look at your sort of possible network architecture approaches. Make sure that your IP range selections are right, and that if you're going to go down a multi-environment, multi-project separation of concerns approach, do you want to have a central managed account approach where all those constraints, controls, and authentication layer and everything is centralized, and be able to farm it out to multiple environments? That'll just determine what style and a model of landing zone approach you might want to take. Most people think of landing zone as like a product, and it can be a canned solution, but really it's just a set of practices and principles and considerations you need to take very early on in your journey. Separate to this, and maybe although slightly related to this, I'll talk about a client I worked with. They had a project started up. They were building a product that they had to host for their clients. Each environment was a multi-Google Cloud project setup. They had multiple Kubernetes clusters, one in each of the projects under a client's environment. And they were hitting a point of management limitation. They were really struggling to manage this setup. And I think what you realize when you look at these situations is they need organization. They need a sort of a starting point to help them flesh this out. So we introduced a more mature approach in terms of infrastructure as code, and we're able to take the simple representation of these resources and concepts in Google Cloud and represent them in a pretty nice structure, and it ended up looking a little bit like this. So client, we were able to use this concept of folders in Google. So under an organization, you could create a folder. We created one for a client, and we created another one for an environment for that client. And then under each of those, we had separate projects for different purposes in that environment. So we had a back end and a front end, say. They're not going to do the exact concept of what the client had. And in each environment, there was a Kubernetes cluster for those purposes. What we ended up doing was using, and underneath all of those projects was the shared network concept. So the project, there was actually a third project in that group which owned the underlying network. And each of the resources in each of the separate projects could use that shared network. So you can understand there was a very complex set of resources, partly out of regulatory requirement and partly out of their desire to engineer it in a way that they could compartmentalize these things. But it meant that they had a real hard time sort of like going through a manual management process to formulate this. And one of the big challenges they had was they needed to spin out copies of these setups for a large list of clients they were now starting to host these environments for. So what we were able to do was use infrastructure as code, templating, and hierarchical data structures to render those environments, because those concepts in Google were so simple to understand. And we ended up with this sort of repeating pattern and re-implementation of the same structures over and over again to extensible lists of these things. And it meant that we could create a really complicated but also manageable and composable version of their entire estate. Something that was surprisingly easy to achieve. And I think giving Google credit for it isn't unfair. I think they have amazingly effective resource representations, and it really helped that that they were so simple we could understand them that way. So that's the end of our stories. I think in terms of what we've talked about today, I'll give you at a high level. We talked about the cloud market, the drivers that are growing, continuing to drive its growth through the next few years, different scenarios of cloud use, the single cloud, multi-cloud, hybrid multi-cloud, as well as then focusing on Google's offerings and the strengths it brings to the market, the networking, Kubernetes, BigQuery, and AI capabilities that it offers. And we've also presented you with some of the financial optimizations and opportunities there are there for your adoption of Google Cloud. And then finally, shared some experiences we've had across the finance and technical elements of Google Cloud. So we hope you've got a better understanding now, and let's hear some of your questions.